We can take a very formulaic approach to calculating the mean or expected value, they are the same thing, the variance and the standard deviation of a binomial distribution. So let's first of all keep in mind the mean and the expected value, which we call e to the x, or we sometimes call mu as well. They're the same thing. And the best way to explain this is to consider that if I had a coin that has heads and tails, and I tossed it twice, I'd expect 1 heads and 1 tails. The mean, therefore, would be 1. If I had a coin, heads and tails, and I tossed it 10 times, the mean number of heads I would expect would be half times the 10 tosses, which is 5. And that's exactly what the expected value is. So in our minds, without maybe even considering it, what we actually did then was a calculation where we said my expected value is the number of events multiplied by the probability of success. And that's the formula for mean for the binomial distribution. Now I want to jump all the way across to standard deviation. And standard deviation talks about how spread out data is. So it's a measure of spread. Now, if you want to see standard deviation in a simpler context, consider having a look at the video on the normal distribution, the introduction to the normal distribution, and that will help you out a little bit more with standard deviation. Standard deviation is the square root of NPQ, where Q equals 1 minus P. So where P is the probability of a desired outcome in our binomial distribution, Q is the probability that we don't have the desired outcome in the binomial distribution. And that's the formula we use for standard deviation. And the variance, this thing in the middle, this is our halfway point to standard deviation. The variance equals NPQ. And so now we have this relationship here between variance and standard deviation. And this always holds in probability, that the standard deviation equals the square root of the variance of x. So that's how we're going to calculate the mean, the variance, and the standard deviation of a binomial distribution. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.